Good morning, students. Once again, welcome to physics class. In the previous class, we have introduced dimension formulas, the concept of dimension formulas. Now, in today's class, we will take few new quantities and you have to learn their physical formulas and to find their dimension formulas. So I am taking, as we have done, 16 dimension formulas up to universal gravitational constant. So now next quantity which we are taking is impulse. See, this is a new quantity. Although this concept is in indirect way was introduced in class 9th. Now I am taking now the term impulse. Physical formula for this impulse is force into time. Force into time. Now we are not in front of each other, but I will tell you, like in a class, put the value of force and time, dimension formula. So do it simultaneously so that you will have confidence whether you are able to write it or not. Force having formula mlt minus 2, time t. So it will be mlt minus 1. Check, we are getting the same results. This is the dimension formula of impulse. Now, next is torque. Yes, torque. Now, another new term. This torque, you can say this is a term related with rotation of any object. Like when any body is moving, like a fan is rotating, like when you are opening or closing the door of your home or window. That means when it is rotating, anything that is rotating, the concept of torque is introduced. See, I will not define each and every term here because it is a very elaborated concept. We have to learn physical formula. That is your work here. So another name for it is moment of force. Torque or moment of force, one and the same thing. What is its formula? Now you will see its formula is force into distance. So you can say this is a formula of work done also, isn't it? So now you can just put the value mlt minus 2 L, then it will be ml2t minus 2. This will be the dimension formula of torque. This is a new quantity. Many physical quantities you will find having same dimension formulas or physical formulas. So don't get confused. Learn the term as well as physical formula. Substitute the dimension formula of each term and get the final formula. Next is force constant. Force constant. Force constant will having a formula force per unit distance, per unit length you can say. So solve it. mlt minus 2 divide by L. What will be the formula? ml 0. L upon L it will be 0. T raised to the power minus 2. So or you can also write it as mt minus 2. Then next is surface tension. Surface tension is a new term that is related with the concept of surface tension for the liquids. When the liquid is at rest, this concept we will study. Where you will study? This is in liquid at rest. This is a property of liquid. So its formula is force per unit length. See, force constant, surface tension are almost have same kind of physical formula, but they are entirely different. This force constant is used when you are taking a spring, that what is a spring constant or force constant for that. Spring का जो particular material है, for that we are taking a particular constant factor. Whereas surface tension is a property of liquid at rest. But physical formula same doesn't mean the physical meaning of quantity is also same. So the formula you can find that will also come out to be same. Next is surface energy. surface energy. This is, don't get confused with the energy. This is an exception. Surface energy is energy per unit area. Energy per unit area. Learn this. This is also used in property of matter, that is liquid at rest. Energy having formula ml, what is it? ml 2 t minus 2. We can retain the formula. Energy is force into distance. Force into distance, so ml2 t minus 2. Area, that is L2. So it will be mt minus 2. It does not make any sense that the dimension formulas are same, the quantities are resembling to be representing to be same. No, quantities are entirely different. Dimension formula is just a formula, nothing else. You have to practice it so that you can just attempt the questions that find the dimension formula of any particular quantity. Now next term is stress. Stress is a term related with the solids, as properties of matter is our one unit in which solid, liquid and gases are the parts. In solid we will introduce the concept of stress, although its physical formula is same as that of pressure, force per unit area. So it will be ml t minus 2 upon L2. So it will be m L raised to the power minus 1, T raised to the power minus 2. Next is strain. Strain. Strain is a term that is taken as change in dimension to the original dimension. Dimension can be length, volume, it can be any. Now to understand this, I am just giving you one example. Suppose this is a wire having length L. Let we are applying a force, let we are stretching it, let del L is extension. Like this wire is 1 meter. When extending, this is given to be 1.1 meter. Very small change on extension by applying external force. So here strain will be this change. It means 1.1 minus 1, that is 0.1 meter. This is change. And original dimension is 1 meter. So basically we have nothing to do with the values. We have to consider the quantity. Here change in length, that is itself is a length. And original quantity is also a length. The ratio of two like terms. Whenever we are taking the concept of strain, we are taking a change in length here. We can take the change in volume here. Suppose you have a balloon and you are blowing it and there is an increase in its volume. There is an expansion. So change in volume per unit original volume. Like ratio of two like quantities. So it will be, if you are taking change in dimension as we have seen here, length upon length. So it is L raised to the power 1 minus 1, it will be 0. Again it is dimensionless. Strain is a dimensionless. Why? Because it is the ratio of two like terms. Now next is coefficient of elasticity. Coefficient of elasticity, it is taken as basically the ratio of stress upon strain. Like we have done this stress and this is strain. So coefficient of elasticity will be the ratio of these two terms, and being strain is dimensionless. So dimension formula of this coefficient of elasticity will be same as that of stress, that is force per unit area. So now you find it. This is m L minus 1 T minus 2. This is coefficient of elasticity. Basically, it is of three different types. What are those? First is Young modulus of elasticity. Y symbol. Or second is bulk modulus of elasticity, B. Or third is modulus of rigidity, eta. So there are three different types of coefficient of elasticity. These are different types. Having formula will be same. That means three different types, but all the three will having the same physical formula and dimension formula. So why I have introduced it here, because when you will use this dimension formula in many different applications, instead of coefficient of velocity, sometimes it has been given that bulk modulus of elasticity for material is given to be this and this, and do this particular concept, just to use it in the application. Actually, you will not get this concept here, because I am introducing here dimension formulas. How these dimension formula will be used in further applications, that will be you will discussing in next lectures. So at this point, just remember that there are three types of coefficient of elasticity having the same dimension formula. Next is radius of gyration. Radius of gyration, simply understand this is a length, this is a distance. This concept will be used in rotational motion. So you have one unit, rotational motion, there this unit will be, this quantity will be used. So you can better just, this is having dimension formula L. Next is moment of inertia. Moment of inertia, symbolically we represent it by I. And its physical formula is mass into distance square. So mass having dimension formula m, distance having L, and its square is there, so you can combine it ml2. Now wavelength. You have studied in 9th class, wavelength, length of a wave, distance between two crust and trough, two compression and rarefaction. What is it? Again a distance, again a length. So its dimension formula will be L. Time period. Time period, capital T. Time taken to complete one vibration. So it is time. Formula will be T only. Frequency. Symbolically, new symbol is used. We have done this also in class 9th. Frequency. This is reciprocal of time period. Time period itself is a time. So it will be 1 upon T. You can take it as T minus 1. Now, next physical quantity which we are taking, that is angle. Angle used in maths. How you define? This is arc length per unit radius. Arc, suppose this is an arc, a part of a circle. This is an arc per unit radius. This is angle. Plane angle I have explained. This is almost same. So arc is again a distance. Radius is again a distance. So you can take it as dimensionless. Directly you can see, because it is clearly it is clear from the formula. Now, very important point I have to tell you about it. Angle is a physical quantity which is dimensionless but having unit. There can be a question, name a physical quantity which has dimension, which has unit but no dimension formula. So answer will be angle. Why? Why? Because its unit is radian. Obviously, this is when we are taking the term angle, this is having unit radian. You can say that a plane angle having unit radian and the solid angle having unit steradian, because both have a type of angle. So you have to learn. Sometimes 1 mark question can be there. Next is angular velocity. Before angular velocity, I will say angular displacement. Angular displacement is not different from angle. Angular displacement you will say, or angle you will say. One and the same thing. What is the dimension formula of angular displacement or angle? You will say that it is dimensionless, but it is having unit radian as that of angle. Now angular velocity. See, now the terms which we are doing, slightly some different task we are doing here, as we have done the concept of like distance, length, velocity, acceleration, linear momentum and all. Here we will take all in terms of angular terms. Angular velocity. See, all this concept arises when we study rotational motion. So just learn the formulas here. Angular velocity is represented by omega symbol, small w curving. Small w we are symbol used for angular velocity. And its physical formula is angle per unit time. So angle is dimensionless. Can I write its direct formula, that is t raised to the power minus 1. Then is angular acceleration. Angular acceleration. Now this acceleration, see, linear acceleration, simply you have taken it by a or g. Here angular acceleration is alpha symbol you are using for it. And this is taken as angular velocity per unit time. So angular velocity is t minus 1 and time is t. Then its formula will be t minus 2. Then after this, angular momentum. Angular momentum. Angular momentum basically, first of all, you know that what is linear momentum? Linear momentum is mass into velocity. Now angular momentum is related to linear momentum. How? This is linear momentum multiplied by distance. Linear momentum multiplied by distance. Linear momentum is mass into velocity into distance. You can take it by r, d, whatever you like. Now find its formula. M L t minus 1 into L. So M L 2 t minus 1. So just see, as I am doing it, what I know that I am just knowing, having a knowledge of formula, then I am taking the formulas, dimension formula of previous quantities and then substituting to get the final result. Don't get panic by just watching so many formulas. It will take 1 week for you people to learn. One by one, just make a habit that you have to learn 5 physical formulas and their dimension formulas. If you are just comfortable, then you can increase the number. You can take 10 formulas. So, and on the next day, when you are doing next 5 or 10 formulas, then don't forget to revise previous formulas. Yes, one important thing, when you have to study physics, give it a writing practice. Don't do oral practice. It will help you a lot. Always give a writing practice while doing physics. Even a definition you have to learn, revise by writing. Now next is angular frequency. Angular frequency, it is having formula 2 pi into frequency. The symbol you can write nu or you can write frequency. See here, 2 pi is a constant. No dimension formula. Frequency reciprocal of time period. So formula will be t minus 1. We have already taken it. Now, after this, velocity gradient. Velocity gradient. Velocity gradient is, that is velocity. When the term gradient is there, any quantity is varying with distance. So it will be velocity per unit distance. Velocity is L t minus 1 and distance is L. So L is 0. What will be the answer? T minus 1. Now, pressure gradient. Again, pressure is varying with distance. Pressure per unit distance. So now pressure. Now you have to just recall pressure. Pressure was force per unit area. And force per unit area, so formula was M L minus 1 T minus 2 upon L. So M L minus 1, this if it will go in the numerator, again minus plus. So this minus 1, this is minus 2, T minus 2. Pressure gradient. Next is rate of flow. Actually, these are not proper quantities. These are the terms we sometimes use. Velocity gradient, rate of flow. So I am just giving you all the formulas so that you will not confuse while solving numericals. Rate of flow. Rate of flow is volume of liquid flowing per second, per unit time. Suppose through a narrow tube or a pipe, water is passing. So what you will calculate, the rate of flow, that means particular amount of volume is passing. That means depending upon the volume of the tube. And in what time the liquid is crossing it. So volume per unit time. So it will have formula L3 T minus 1. Next is distance traveled in nth second. When you say distance, it is simply length. But when you are saying distance traveled in nth second, actually there is one derivation in second unit, that is kinematics. So here in that unit you will use this particular explanation. What is the meaning? Here I am taking, when you are taking a distance traveled in nth second, it is distance per unit time. That is L T minus 1. So how you will recall, this is nth second. When such kind of word is given in the statement, then this you have to use this formula. So these are few formulas which I have introduced. Now some new formulas I am also taking. I think we have covered almost 37, 38 physical quantities and their formulas. And after 16 all were new terms. And you have to just pay more time to learn the formulas. And few more terms I would like to take, just for, you can say that 7-8 terms I will take. After that you have to learn all these. So I am just taking few more terms. First is Planck's constant. Planck's constant. Planck's constant, that is a fixed value. It will be used in physics as well as in chemistry. And the physical formula for this is energy per unit frequency. So now energy and frequency you are familiar, but Planck's constant was a new term. So now put the value for energy, M L2 T minus 2. And frequency is T minus 1. Solve it. M L2 T minus 2. This minus 1 is coming in numerator, plus 1. So here what will be the final formula? ml2 T minus 1. This is Planck's constant. Next is coefficient of viscosity. The concept of viscous force, viscosity. I will simply say when the liquid is in motion. How thick a liquid is. Just giving you an example here, just for understanding the term. Water, oil, ghee, honey. When you are taking, water can flow easily. Oil will be slightly lesser flow as compared to water. Honey, more thick. When you will just drop it, it will take certain, it will just fall at the point, it will not start flowing on its own. In comparison to this, which is having just thicker consistency, that is more viscous. So this factor, coefficient of viscosity, determine that consistency of the liquid. You will study it in detail in properties of matter unit, that will be liquid in motion. So coefficient of viscosity is having the formula you have to learn. This is force into distance upon area into velocity. This formula is slightly difficult to learn, but you have to learn within few days. You will get confidence over this formula. Now force, I will solve it. mLt minus 2. Distance is L, area is L2, velocity is Lt minus 1. Now rearrange here this L and this L. Let me arrange it L2, T minus 2. Let me rearrange the terms in denominator also. L3, T minus 1. Now take all the terms in the numerator. M1, L raised to the power 2 minus 3. T raised to the power minus 2 plus 1. So what is the formula? M L minus 1 T minus 1. This is coefficient of viscosity dimension formula. Directly you can learn, this is used many a times. ML minus 1 T minus 1. Next term is Reynolds number. Symbolically we can represent it by N or NR, R is the suffix. No need to learn its physical formula. Directly here you can say this is dimensionless, or M0, L0, T0. Then refractive index. Refractive index is a term that is, you have studied in class 10th, there you were using the symbol and for it. It was speed of light to the speed of light in a medium. Speed of light in air or vacuum to the speed of light in a medium. So ratio of again speed or velocity. So again it is a dimensionless. M0, L0, T0 or dimensionless. Then velocity types we are taking. Escape velocity. Escape velocity, this concept is used in gravitation. Escape velocity, that is, we'll talk about of a planet. It will have a physical formula under root of 2gr. Small g is acceleration due to gravity. R is the radius of Earth. Symbolically it is clear. R radius, g acceleration due to gravity. So now substitute the value. 2 is a constant. No dimension formula. G Lt minus 2 and R is L. Within the under root, again solve it. L raised to the power 2, T raised to the power minus 2. So now outside under root sign when we'll take, this will be L raised to the power 2. So outside it will be L and it is T minus 1. So this will be the dimension formula for escape velocity. See, this is same as that of the general velocity or speed we are taking. Similarly, orbital velocity, different kind of velocity you will study in class 11, but you can directly take their formula to be LT minus 1, or if you want to relate it by the physical formula, this is the physical formula of orbital velocity. Under root of g r. Again, g is acceleration due to gravity, r is the radius of the planet. So again, it will be LT minus 1. You will solve it by yourself. This is homework for you. Then critical velocity. Critical velocity is having formula Reynolds number multiplied by coefficient of viscosity. Eta is a symbol for coefficient of viscosity. See here, eta. When you draw, just how to write n, and you write prolong its back length. So this is eta symbol for coefficient of viscosity. So here critical velocity is Reynolds number multiplied by coefficient of viscosity divided by density into diameter. This is also homework for you. Solve it, that will come out to be LT minus 1. Now, centripetal acceleration. This concept is used when a body is moving in circular path. Then we are discussing the concept of centripetal force or centripetal acceleration. So first of all, we are taking centripetal acceleration. This is having physical formula velocity square upon, that will be radius. You can say v square by r, that is radius. You can take radius of circle. Put the values L t minus 1 2 upon L. Expand it L2 t minus 2 upon L. So it will be LT minus 2. See, this formula is same as we have done for acceleration due to gravity. It will having the same formula as of simple acceleration. Now, mechanical equivalent of heat. Mechanical equivalent of heat. This is having formula work per unit heat. Work and heat. Heat is a form of energy. The ratio of two like quantities. So again it is dimensionless. You can check it. This is again dimensionless. And it is having unit joule per calorie. This is a quantity which is dimensionless and having unit. Next is thermal conductivity. So its physical formula, thermal conductivity, that is having formula heat energy multiplied by distance divided by area, temperature and time. Actually, the concept you will understand when you will study it. But here you only require formula. Now you can see heat energy, you know, distance, area, temperature, time. Here it is temperature, a new basic quantity is introduced. Up to now, majority of the quantities are depending upon only mass, length and time. But here temperature has been introduced. One of the 7 basic or fundamental quantities. Now how to find dimension formula? Heat energy mL2 T minus 2. Distance L. Area L2. Temperature K. Symbol will be K. Time is T. Now solve it. Arrange numerator and denominator. mL3 T minus 2 in the numerator. Here L2 KT. Arrange in the numerator all the terms. m L3 minus 2 t raised to the power minus 2 minus 1 k raised to the power minus 1. It is m L t minus 3 k minus 1. So this is the dimension formula of thermal conductivity. So I have taken 46 formulas, maybe one more or less, you can check. So these formulas I have, you have to learn the dimension formula and physical formula of all these. There can be other formulas also, but I will not recommend right now to learn those formulas, to go at those formulas. When you will have 100% confidence of all the concepts and applications, then you will just revise extra concepts. You can just go through that from your books. But now, work for you all. Today you will practice first 15, or if it is more you can revise only 10 formulas along with the definitions we have done. Learn the method of how to write dimension formula. Today you will do one thing, just revise these. Tomorrow I'm telling you that what you have to do tomorrow. Tomorrow you have to revise. If you, it will be better if you can revise today 15 formulas. So tomorrow you can take next 15 formulas. Do it. After that I will tell you that how to learn it, how to just rearrange it. First of all, you have to just separate them in groups. So revise by written practice first 15 formulas. And any doubt, you can contact me anytime. Thank you. Have a nice day.